Now we are going to prove the Pythagoras theorem. So the Pythagoras theorem said if we have a right angle triangle just like that, ABC, so the hypotenuse, which is AC, the longest side in the triangle, equals the AB power 2 plus BC to the power 2. So the hypotenuse squared, which is AC, equals the AB squared plus BC squared. This is Pythagoras theorem. So let's try to prove this one. So first of all, let's suggest what is the length of this triangle sides. So let's say this is A centimeter. So and let's say this is B centimeter, and say this is C centimeter. So now I have the length A and B and C. So now let's try to make a copy of this triangle and paste it to make another shape just like the following. This is the second one, and now let's know the length of the side of the sides. So now I have this is B and this is A, the longest, and again this is C. So just copy the triangle and rotate it to be like that. So now after that I have to draw a line. Let's make a line just like that, drawing from this point to this point. So consider this is a line. So now let's name again ABC. So let's make it D, make it E. So now the case is how to get the area of this trapezium ABCD. So now the whole shape, I need to know the area. So I have two methods to calculate the area. So let's talk about the first method. So the first method to calculate the area, the first method is by calculating by Trapezium Rule. So the Trapezium Rule is the sum of the two bases divided by 2 and then multiplying by the height. So now we have to know that this is the height, all of this is the height, BE, because I have these two parallel lines, because I have two lines 90 degrees, so they are parallel, of course. So now I have this length is A plus B. And concerning the two bases, one called B and one called A. So now I can calculate the area just like the following. So the area of E, B, C, D, just like the following. The half times the sum of two bases, which is A plus B, and then times the height, which is A plus B. So now I have half times A plus B all to the power of 2. So now let's expand the bracket A plus B all to the power of 2. So the result is half and then A squared plus 2AB plus B squared. So now I have the area of the trapezium by the first method. We have another method to calculate this area by calculating three areas. The first one is this triangle, and the second one this triangle, and the third one is this triangle, and adding them together. So let's make it by the second method. So I can say the second method to calculate the area of the same figure. So the first of all, let's calculate the triangle number 1. So the area is half times base times height. So now it's right angle triangle, so I can consider this is base and I can consider this is right. So now the height, sorry. So now I have half times B times A. So this is the triangle 1. This is the area of triangle. But I have two triangles the same. I have this is the base, this is the height. So again, half times A times B. So now I can say this is the first triangle. So the second triangle is the same, half times B times A. Now let's go to the third one. The third one, I need to know what is the area of the third. Now you have to know that I have this angle, just like this angle, you know, because they are congruent triangles, they are the same. So again, this angle just like this angle. And you know that this is 90, so this angle plus this one equals 90. So again, I know that this one just like this one. So it means that this angle plus this angle equal the same 90. So the remaining is 90. So now I have a right angle triangle just like that. So I can calculate the area of this triangle by using half times base times height. And I can consider it base and I can consider it height again. So now I can say the third triangle equals half times base, which is C, times height, which is another C. So now to know the area of the trapezium, so the area of the old shape ABCD, just like the following. adding the area of the first triangle and the second and the third. So it is half AB, which is the first, plus half AB, which is the second, plus half C to the power 2, because I have C times T, C squared. So now I have two methods to calculate the area. So they are equal, the first method and the second method. So let's make this equality. So therefore that I have half, which is the first second, guys, half A squared plus 2AB plus B squared, just like equals half, and I can take it as a common factor, so I can say half times AB plus AB plus, no, I'm sorry, this is no half now, yes, plus C to the power of 2. So now I can say half cancelled with the half. So in result, I can say A squared plus 2AB plus B squared equals AB plus AB, which is 2AB plus C squared. Now I can remove that 2AB from the left hand side and 2AB from the right hand side. So the remaining is A to the power 2 plus B to the power 2 equals C to the power 2, which is we are trying to prove. So now I can say A to the power 2 plus B to the power 2 equals the C to the power 2, which is Pythagoras theorem. Thank you for listening and watching. It was Assem Hangal with you. Thank you. Bye.